Hello, I guess we'll get started. Welcome to my talk, in-depth path morphing. I hope you can see my slides. I didn't prepare for, standing in front of it like this. My name is Alex Lockwod. I'm a Android developer at Lyft. I've been doing Android development for since, I don't know, Honeycomb or something, however long that is. You can find the slides at j.mp/pathmorph if you want to follow along. And I've also posted them on Twitter at AlexJLockwood. So yesterday Mark gave a talk about vector drawables and animated vector drawables. And this talk, I guess, is kind of like a extreme deep dive into the very last slide of his talk, where he showed how to animate between a sun and a moon. And what that animation made use of was something called path morphing. And so these are kind of the classic examples of path morphing I can think of. On the left, or on the right, you have the Pocket Cast app and then the timely alarm clock app. And as you can see, unlike animations where you're animating a numeric rotation or scale or something like that, these are actually animating the shape of the object. And it's kind of hard to wrap your mind around how this works at first. I definitely remember a time when, I think the first time I kind of understood was when somebody wrote a blog post about the timely alarm clock app and explained how path morphing works under the hood, and it was kind of like a mind-blown moment at the time. But hopefully by the end of this talk, my goal is kind of you'll all understand how it works, because it's not actually super complicated, although not very intuitive if you're just looking at it. So path morphing isn't just specific to Android. It's also pretty common on the web. It's only been made available to Android recently using animated vector drawables. So this is a article from NPR about gerrymandering in North Carolina. I guess a couple years ago, there was a bunch of litigation with regards to the court districts there. And I guess this kind of makes use of path morphing by adding time as the third dimension and sort of showing the before and after states of the districts. Again, you can do this using vector drawables. This is using SVGs in a JavaScript library called D3. And at the very extreme end of things, here's a pretty cool animation I found online. This is written using Adobe After Effects. You can use libraries like Lottie to programmatically convert those Adobe After Effects projects into native animations for the web or Android. Although these are also the types of things you'd probably see in television commercials or games. So it's definitely not just limited to mobile or the web. It's actually kind of widespread. But before I go much further, I just want to give kind of a brief overview of how exactly this works. Before you can animate an object's shape, you have to know how to draw it. And to do that, you use something called the SVG path data spec. You may have saw it in Mark's talk yesterday. And you can kind of think of it as a pen floating on top of a virtual canvas. And what you do is you just sort of issue these drawing commands. And as you go along, you just move the pen and draw. And these are the commands you use to draw a square, for example. A move to command and then 4 lines. There are also commands for curves, as you'll see later in this talk. The spec is pretty large. It's there are commands for quadratic curves, Bezier curves, arcs. In this talk, we'll just be talking about, I think, M, L, and C to keep it simple. So if you wanted to morph that square into another square or another shape, this is how you do it in Android. You declare an object animator like this, and this object animator is animating the path data property of a vector drawable. So an object animator's job is to generate the in-between states throughout the duration of the animation. And the obvious question here is, how does this object animator generate those in-between states? Because if you had something simple like an object animator that animated like a alpha value from like 0 to 1, it'd be obvious, right? You just go like 0, 0.1, 0.2, 0.3, etc. But what is halfway between these two path strings? And to kind of visualize how it works is you can sort of stack those two strings on top of each other like this and just sort of go through each command. And with each command you ask, what is halfway between these 2 points? And if you do that for each pair of commands, you'll end up with this intermediate state, the path string that will be used by the object animator at time t equals 1/2. It should be clear from this, though, that one of the requirements is that the SVG paths have to have the same number of commands, and they have to have the same type of command. In this case, you have an M and 4 L's on both sides, and both draw a square. And this is a visual example of what that exact object animator was doing. And you can see that if you run the morph, it looks like it's just translating that square into a new position, but what's really happening is the object animator is creating all these hundreds of intermediate states at each on each frame. It gets the current animation fraction, and then goes through that process of asking what is the point between these two start and end points, getting that position, invalidating the view, and then redrawing. And if there's one thing you should take away from this talk, it's that path morphing is really just it's really just the movement of points, right? If you took any given path morph animation and you drew the points on top of it, you just see them sort of migrating from their start to end state, following a straight line. And in each animation you'll see in this talk, that's kind of how it'll work. Each animation in this talk will just take the points from the start state and then sort of translate them to the end state. And you can get a lot of cool, nice effects using this approach. So we start to run into trouble, though, if we are trying to morph a square into an octagon, right? Because now we have these 4 lonely points in the octagon that have no partner on the other side. And if you try to morph them, you get something pretty ugly like this. This is actually the default animation you'll get if you try to morph 2 SVGs together on the web. On Android, though, you'll get an exception. It'll just crash your app and say, these 2 paths don't have the same number of points, so the object animator isn't going to know how to draw it, so you should stop what you're doing and fix the resource. So how do we fix this? Well, to fix this, we introduce the undercover octagon. And the undercover octagon is a dapper, well-traveled octagon with many disguises. What I mean by that is, so we have this square on the left, this octagon on the right. We need to add 4 points. And by adding these 4 points to the square that don't, affect the visual result, we've turned that square, from the computer's perspective at least, we've changed that square into an octagon, right? This this shape has 8 sides, has 8 points. It still looks like a square, but when we morph them together, now you'll get something really smooth looking like this. And this strategy of adding dummy points is really important because it's not often that you have 2 shapes that you want to morph together with the same number of points. It's kind of a chance thing. So we've talked about morphing lines, but what about curves? And you can kind of apply the same logic here if you draw the handles for those curves. So a Bezier curve is a curve with 2 endpoints and 2 control points. Once you draw those control points, you can sort of see it sort of works the same, right? You're just moving those control points to their new location and redrawing on every frame. But if you try to morph a line into a curve, you're going to have problems because not only are there an unequal number of points on both sides, but now you have an L on the left and a C on the right. And this is probably why the framework will just crash your app immediately, right? Because it's not going to know which one to use. But what you can do is, I guess you can call this the undercover curve. It's a line, or it's a curve that looks like a line, but it's had its control points placed on the line that connects the endpoints. And when you do that, you get a cubic Bezier curve that looks like a line. And now you can get a smooth animation like this. Taking that a step further, if you have an octagon and you want to morph it into a circle, you can sort of do the same thing. You can just take each line in the octagon, convert it into a curve, and you get something like this. So it looks pretty nice. So there's actually a second problem that we have to solve though. And that is that the order of the points in the shapes matters. So it's not enough to crash the app, but it can pretty hugely affect the final animation. So earlier we morphed a square into an octagon, but now let's say your design tool or Sketch or whatever you're using, let's say that it exported the points like this. Before the 1 was on the top, but now we've shifted them over a little bit. When you do that, you get an animation like this, right? And probably not what you wanted. Even worse is when you have the order of the points and you reverse them. And when you do that, you get this really weird looking animation like this. And this is going to be a deal breaker because you need to have your points ordered in a way that makes sense for your animation. So to recap everything I just said, the paths that you try to morph need to have the same number and same type of commands. They need to be what we call compatible with each other. You can use tricks like adding dummy points to the shapes to make sure that the shapes have an equal number of points. And you can use tricks like converting lines into curves. And lastly, the order of the path points matters a lot. If the order of the points are reversed in one shape and not reversed in another, you're going to get something that probably looks pretty weird. So before we go any further with this, I just want to sort of take a second to explain how I became interested in this. So it kind of started a year and a half ago, I'd say, when I wrote a blog post called An Introduction to Icon Animations. And I was really proud of it. I wrote all these interactive demos on how animations work, and I built this sample app with a bunch of sample AVDs with the hopes that people would start using vector drawables more. But publishing it was also kind of bittersweet because of how hard it was to create them. Especially the path morphing animations, I'd it's easy to see, you know, like where points should be, but it's really difficult to like manually go into these SVG strings and like shift the points over by hand. And it's also, there's a lot of math involved in like splitting curves and stuff like that, and it's just kind of a mess to do all that by hand. So around the same time, Nick Butcher wrote this cool blog post explaining how he wrote this path morphing animation, this like little jumping pin thing. And we got together and agreed that it was super hard to write these, and that, you know, there should be like an easier way to create these, basically. Like, we shouldn't have to be doing all this math by hand in order to do it. We shouldn't have to, you know, ideally, like, the designers would just give us something that would work immediately, and we could just write it and it would take like 10 seconds or something. So we got together and we kind of like made a list of everything that we didn't like about this. The first was that the design tools don't expose the order of the points to you. Like, if you're using Sketch, this Sketch doesn't expose a way to like shift points over, because, you know, it's a design tool. It doesn't care what order the points are, and it just cares, you know, what is the visual result. You know, another problem is that design tools don't allow you to overlap points on top of each other easily. So like, that's a common strategy when you're adding dummy points, is a lot of times you want the dummy points to be, you know, stacked on top of each other, and with Sketch it's just not easy to do that. Like, you'd have to like zoom in and just like kind of drag it like really, really, really close, but not exactly on top. And we also found that it's really difficult and time-consuming to visualize the in-between states of these animations. Like, what we ended up having to do was, like, you know, we'd modify the SVG path string, and then we'd install the APK, and then we'd run the animation, and then if it didn't look right, we'd like modify the path string and install the APK and run the animation, and it was just a really slow process. So you know, that being said, we sort of said, what if there was a tool that allowed us to, you know, do everything that would solve these problems? You know, create dummy points, convert lines into curves automatically, so you didn't have to, you know, worry about any of that math. Reorder the points, you know, whether it's shifting or reversing them, and then finally just export it to vector drawable and animated vector drawable immediately. And this is kind of how the idea of Shapeshifter was born, which is sort of the app that I spent, you know, the past year or so writing just to sort of solve these problems. And I want to give a brief example of how to use this tool. So this video, I'm going to show you how to create a plus to minus animation. So what I've done is I've dragged SVG files into, you know, the tool. I'm going to create a path data animation. And what I'm going to do up here is I'm going to copy the minus path into that to value. You see that it's also giving me this warning that the paths aren't compatible, and what that means is that the minus and the plus sign don't have the same number of points. And it's red because if you tried to run this animation in the Android app, you'd get a crash. It's also suggesting I use this thing called autofix, which is something I'll talk about a little bit later. It's going to magically try to fix everything for me. But for the purposes of this, I'm going to enter this edit path morphing animation mode. And the first thing I'm going to do is I'm going to, so first of all, the plus has 12 points, and the minus has 4. So I'm going to add 8 dummy points to the minus. So you can see I'm just sort of like adding them randomly. And once I add those 8 points, everything becomes blue, which means nothing is going to crash anymore. But that doesn't necessarily mean that the animation is going to look great. As you can see, it looks pretty bad. And that's because the points are shifted in a way that's not ideal, right? Like the 1 is in the top left in the minus, and the 1 is on the bottom right in the plus. So I'm going to shift them all over. It still looks bad, and that's because the points are reversed in the wrong way. So I'm going to reverse the order of the minus sign, and when I run that, I get something that still doesn't look good, but that's because the dummy point locations aren't ideal for this animation. So I'm going to drag them down into these locations, and once I do that, I get something that looks like what you're going to see right now. Yeah. So that is kind of the simplest example you probably do. I also want to give a more complicated example. I'm gonna animate an arrow into an overflow icon. So the difference here obviously is that the design tool you're using is probably going to export the arrow as one shape, and you need to morph that into 3 somehow. So one way to solve this is by slicing up that arrow into multiple shapes. And if we do that, we can sort of pair subpaths of each shape and morph them individually. So I'm using this tool that allows you to identify where you want to slice up the path. And once you do that, you can use this pair subpaths tool to say like, okay, I want this middle arrow to morph with the middle circle, and the same with the top and bottom. And once I do that, it's still red, and that's because I need to add 3 dummy points to this middle circle over here. And once I do that, I get something that looks like this. So just to be fancy, I guess, I'm going to add a little bit of rotation. I find that adding rotation to path morphing it makes the result look a lot nicer in a lot of cases, I guess, because it distracts the eye from what's actually happening. So you can see here, once you add 360 degrees of rotation to this animation, then it sort of, I guess, the animation feels a lot like more seamless. Like you don't really know what's happening. You just know that they're like seamlessly morphing into like one state to another. And I guess, that it works pretty nicely, that effect. And so this is what it looks like when you export. It looks super complicated, but fortunately, all you have to do is you just have to drag this into your resources/drawable folder or whatever, and just use it in your image view, and that's it. You can also export to SVG sprite sheet. I've gotten requests for body movement because I don't think iOS has support for any of this stuff. Like it doesn't have a vector drawable or SVG equivalent. So I guess if I were to export to body movement, maybe it would also be compatible with them. It's a work in progress. So sorry, I went to the next slide a little bit early. That was at shapeshifter.design if you missed that. So here are some examples of morphs that I created while I was sort of writing this. And it was, as I was writing the tool, kind of like what I would do to debug was I would just pick random icons on the material design site and just like morph them together and try to find the best looking morph between 2 states. I guess these are kind of the ones I liked the best. So those were all pretty simple, but what if you want to do this? This is much more complicated because the hippo has something like 100 points. The elephant has, I think, like 60. In order to create this using Shapeshifter, what I had to do was I had to like import them and then add like 50 points to the elephant, and then it would finally not crash, but then it still didn't look good because the 50 points were in the wrong place, and then I had to like move the 50 points to the right place, and if it still didn't look good, I had to like add points to the hippo and then add more points to the elephant, and it was just like really, really time consuming. So I kind of like had this idea of something called autofix, and we saw this earlier in the video that I just showed. But one of the design goals of Shapeshifter was to not be something that would be 100% automated, because I found that those sorts of tools exist already on the web, but in a lot of cases, the automated animation isn't exactly like the effect that you want. And if it's not something you want, you're kind of just stuck with it. And so I guess Shapeshifter kind of was written like very specifically to avoid that. Like I wanted to have full control over where points were. But kind of after I went through that, the elephant and hippo and buffalo example, what I thought was, what if there was a way to like get halfway to where I wanted to go? Like, what if there was an algorithm that could sort of like add points to where the points should go or something, and what if I could get like halfway to where I wanted to be, at least I wouldn't have to go through the process of like adding millions of points by hand, basically. So the first key assumption I made when going about this was that the animation that looks the best is usually the one where the points travel the least. All else, I guess this makes sense intuitively because the less distance between points, the less likely you'll get an effect like this, where the points are overlapping on top of each other and creating some like really noticeable, obvious, inverted state. So, with this assumption, I sort of took a crack at this. It's a 3-step process. This is kind of like the naive, first attempt. The first step is to basically just add dummy points. I found that adding a ton of points like this would it would result in like nicer effects, I guess, because the variation was it was like less likely for 2 points to be paired together that are like unnecessarily far away. And once you have this, you can pick a starting point. You can see here it's sort of like evaluating every possible orientation of the points in the star. Calculating the sum of like all the distances and then picking the orientation where the distances were least. And then once you have that, you can morph them. And like I said, this worked pretty nice. Here's an example of sort of, a combination of the animals and the circle and star. The green points are the ones that are being added for the purposes of animation, and the purple ones are the ones that were there to start with. And the pros of this approach were that, for one, it was pretty easy to implement. It was just like 3 steps, nothing super complicated. And the results were often pretty nice, I guess, because, like I said, when you add so many points, you're kind of like decreasing the chance that you'll have some weird inverted state as you morph them together. But there are also some cons. For one, as you can see, it's sort of adding like way more dummy points than is probably necessary. And this matters in Android because AVDs have to be compiled into your app. And the more dummy points you add, the longer your SVG strings are, the longer it takes to inflate them. When you first open up a screen, the more expensive it is to issue, the drawing commands, the larger the APK size, and I guess it was also, for the purposes of Shapeshifter, it also didn't really make sense because my whole idea was to make something that, would make it like fast to use Shapeshifter. And by adding all these dummy points, I was kind of defeating the purpose. Like if this algorithm gave me something I didn't like, I'd have to like either delete all the points or like move a bunch of points around, and it just wasn't, I guess, ideal. So I went back to the drawing board. I remembered an algorithm I learned in college called Needleman-Wunsch, in search of a more intelligent way of placing dummy points. Needleman-Wunsch algorithm is a dynamic programming algorithm. It's used in molecular biology to align DNA sequences. And I know that sounds random, but there's a connection. But first, I just want to, just a brief example of, what this algorithm does is it takes 2 strands of DNA, and here we have, 2 sequences of nucleotides, and when you pipe it through this algorithm, you get an alignment. And if you're a scientist, what this alignment tells you is if you had 2 species of animals, for example, and you wanted to see how similar they are, you could use this algorithm, and this result might tell you, like, oh, over the course of evolution, this pairing of C and A mutated, or these 3 nucleotides got inserted into the DNA strand. There are also extensions to this algorithm that allow you to prefer pairings of certain nucleotides. So, for example, a C is more likely to mutate into a T. So you can tell this algorithm, I want to prefer alignments that have pairings of C and T over pairings of C and A or C and G. So back to the path morphing. You're probably wondering how this all connects, but basically, what if you could run this same process over SVG strings? If you run this algorithm over these 2 SVG commands, you can get an alignment of the 2, and the gaps in the alignments are where you would insert the dummy points, and the red mismatched pairs are you just convert that L into a C that looks like an L. You can extend this algorithm using kind of the same approach by saying, I want to prefer pairings of L's that are closer together rather than far away. So, like, for example, if you wanted to align a MLLL with MLLL, without that extension, it would, you wouldn't be giving it any information. It would just output, the same strand of DNA. But with this extension, you can get an alignment where the alignment is giving preference to commands that are closer together rather than far away. This is sort of the result, and it looks a lot nicer. And the thing I like most about this is that it's very aware of where points should be placed. So, like, for example, you can see here in the hippo's ear, you need a lot of detail to express those drawing commands in order to get that shape. Whereas with the elephant, the trunk can just be expressed with like a single, 1 or 2 curves or so. And what this algorithm tells you is it tells you, there should be a lot of dummy points in this elephant's trunk in order to get a smooth animation. The downside kind of is that it's a little slower. It's, like I said, it's a dynamic programming algorithm, so it's L1 squared. But since Shapeshifter was a compile time tool, I figured it probably doesn't matter as much because it's not going to affect runtime performance or anything. And the benefits were enough for me to sort of discard that naive approach I took earlier. So up until now, we've talked about morphing single shapes of each other, but what about multiple shapes? And you can sort of think of, I guess, you can sort of create these dummy subpaths, I guess is what I call them. You can see here that this circle has an outer radius and an outer circumference and an inner circumference, and you can see in the star it's it's probably being exported as one shape by your designer, but if you create like this stack of points on top of each other in the center of this star, you can get something that has this really nice like vortex effect where the points are all being like sucked in towards the center, and it works really nicely. You can sort of apply the same approach to things like this, where if you wanted to morph Texas into the 8 Hawaiian Islands, you could sort of pair Texas with the largest Hawaiian island, and then just sort of shrink the Hawaiian Islands out of existence. This actually works pretty nice. In this case, it looks it doesn't look great, but in most cases, it actually works pretty well. For example, with that animation that Mark showed yesterday, where you're morphing a sun into a moon, you could probably do the same sort of thing, where like you morph the moon with the circle that represents the sun, and then you have 8 subpaths surrounding the sun that are just the rays of sunshine, and you can sort of shrink them out of existence. But like I said, it doesn't look great a lot of times, or maybe, I don't know, like half the time. I guess it depends on the animation. But basically what I was thinking, like, what if there was a way to automate the splitting of the shapes? Like, what if there was a way to automate, splitting Texas up into, subpaths so that they could be paired with those Hawaiian Islands and, create a more, smooth animation. And so I took a crack at this. I was sort of like researching, ways to split up shapes, and I discovered this fast JavaScript library called earcut that outputs like it takes a shape as input and then outputs a triangulation of the shape. And triangulations are really important for like low-level programming. It's common in WebGL. GPUs tend to only like to draw triangles, and so there are libraries out there that allow you to split up a shape into a bunch of triangles so that you can send them quickly down to the GPU to render cool 3D meshes and stuff like that. So it's a 3-step process again. The first step is to triangulate Texas. You get something that looks like this. It's way too many triangles. We only need 8, but that's okay because the next step is to merge 2 neighbors and repeat. So you can see here, sort of like 99 triangles appear, sort of. You're picking a triangle at random, and then you're merging it with a neighbor, and you do that enough times that eventually you'll be left with the number of shapes you want. And once you do that, you can sort of compare the centers of these shapes or whatever, and say like, pick the 2 shapes that are closest, pair those together, do that with the rest of them, and you get something that looks like this. Here's a kind of totally gratuitous example of how you do this with the animals in the circle and the star. You can see that it looks pretty nice in this case. This isn't actually something that was added to Shapeshifter yet because I felt like it wasn't perfect. But you can see, for example, like with the elephant, it sort of results in these long slivers of shapes. That might just be because maybe the triangulation approach isn't the best approach. It's just sort of one that I tried. And I figured like with Shapeshifter it's not that hard to just manually slice up the shapes anyway, so maybe there's no need for this, but I guess we'll see. So that is kind of as far as I got with Shapeshifter up until this point. Again, it's on the URL is shapeshifter.design if you want to check it out. I want to talk about a little bit of stuff that I've been working on. So I haven't, I think the last sort of like major shapeshifter release was like maybe like August or something. But you know, I guess I know I should be like plugging this, but I'm like the biggest critic when it comes to shapeshifter. Like sometimes I just can't stand using it, and I think I think that's because like whenever I open it, I expect it to work like a design tool, and so this is something I've been working on sort of in my free time. I try to like work on it a little bit every weekend. It's actually like a lot of work to write something like this where you're like trying to simulate everything you'd expect in a design tool. But I feel like it's somewhat necessary just because I get a lot of like requests for like videos and stuff, like how to use shapeshifter, and I feel like I could do that, but a lot of the reason why people need those videos in order to learn how to use it is just because it's not like intuitive enough to use. Yeah, I mean, like I said, this is just something I'm working on in my free time. As for my like vision of like what I want shapeshifter to be eventually is so like here's a video of how you would write an icon animation in After Effects. I don't know if you've ever used After Effects, but icon animations are probably like the simplest possible thing you can use. You can write using After Effects. As you can see, there are like a ton of presets. There's a ton of stuff that we don't need at all, like audio, 3D stuff. All I want to do is write this simple animation, and I don't want to have to pay $500 for After Effects in order to do it. I guess the sort of long-term goal of shapeshifter is to create something that's like a simple, dumbed-down, free version of this that you can like just access in a browser. I know it sounds simple when I say it like that, but it's there's a lot of stuff that needs to happen in order for me to get that far. So here's some links. The tool is completely open source. It's free, and I want it to always be free. I've set up an Open Collective account. You can see these are the people who have donated so far. I think there's actually one more that may have donated today that I didn't get to add, so thank you. But yeah, so here are some links. I want to give a special thanks to these three people. So I mentioned Nick before, and Roman is also a Googler. They're both developer advocates, and while Nick was sort of the person I talked to a lot about, the stuff that needed to happen in order to make this tool, Roman was also pretty involved in the early stages, and he gave a lot of insight into like how to design the tool. And then Noah Veltman is not an Android developer, but he has a similar talk about path morphing that's very specific to the web, and I think it's called pulling a polygon out of a hat. So if you have 30 minutes, I encourage you to check that out too. And that's all I have. You can find the slides at Alex J. Lockwood or at j.p/pathmorph. Thanks.